Hello everybody and welcome to my new SQL Server Quickie. In two of my last SQL Server Quickies I have talked about two physical join operators in SQL Server, the nested loop operator and the hash join operator. Today we will continue this discussion by talking about the merge join operator, the third and final physical join operator that SQL Server supports. The merge join operator has an important prerequisite. It needs sorted input to perform the join efficiently. Without a sorted input, the merge join can't be performed. You can achieve a sorted input in two ways. Either you can work on your indexing strategy and create an index that the query optimizer will afterwards reference in the execution plan. Creating an index will physically pre-sort the data. Or, without a supporting index, you let SQL Server introduce the necessary explicit sort operator in the execution plan. This provides the rows in the correct sorting order to the merge join operator. But pre-sorting the data with an explicit sort operator is not really the most efficient way because you introduce additional CPU overhead and the so-called memory grant. Let's switch now over to the flip chart where I will describe the merge join operator to you in more detail. I want to show you now on the flip chart how a merge join operator works in SQL Server. As you can see, we have two tables, table A, table B, with some, let's say, ID values in an ID column, and now we're performing a merge join operator in the execution plan. As I've already said in the introduction, a prerequisite of a merge join operator is always a pre-sorted input. Pre-sorted input can be achieved by applying an index in SQL Server, clustered index or non-clustered index, and on the other hand, if the query optimizer introduces a merge join operator without pre-sorted input, SQL Server can also introduce an explicit sort operator in the execution plan. We have here pre-sorted input, so when we look on our execution plan, we have a table A, we have a table B, both with sorted input, and finally we have our merge join operator which performs the merge join and finally emits matching rows to the upfront operator like a select operator. So what SQL Server is doing? SQL Server starts on the outer table by reading first record has a value of 1, and then we're reading through the second table, the inner table, table B in our case. As you can see, for the value of 1 we have no match, so we are doing nothing. Then we move forward to the next values, value of 3, you can see we have one match, means one row is emitted to the next upfront operator in our execution plan. Then we move forward on the outer table, value of 5, a match, row is emitted, values of 6, we have two matching rows, means those rows are again emitted, value of 9, no match, value of 11, one match. Finished. As you can see, a merge join operator is very efficient because you're just reading every input table just once. Therefore, we have also the prerequisite of the sorted input. As another side effect, it's very important that you have no non-unique values in your outer table. As you can see here, we have here multiple duplicate values. Means when you have duplicate values in your outer table or the query optimizer thinks that you have duplicate values in your outer table, then SQL Server also has to create a so-called work table in the public toilet of SQL Server, tempdb in our case, and that work table will also hurt your performance. So if you know that you have unique values in one of these tables, please always make sure to create a unique index on that table, on those columns, so that you are communicating that fact to the query optimizer. Let's switch over now to SQL Server Management Studio, and I will show you with a concrete example how a merge join works within SQL Server. As a prerequisite to this demo, I have already created two tables that we will join with a merge join operator. If we look at both tables, you can see that we have unique values in column 2 on which we will perform later our join. By now we haven't yet created any index on these two tables, therefore the query optimizer has no idea about the uniqueness of that data. Because the query optimizer wouldn't choose by default the merge join operator on our current table schema, I have to hint SQL Server in the next query to enforce the merge join. When we have a quick look at the execution plan, we can see that the merge join is performed and that SQL Server has to pre-sort every input table with an explicit sort operator. Because of the sort operator, this query also requests a memory grant of 1 megabyte. We can see that information in the select operator of the execution plan. We can also see that the outer table is table 1 and that table 2 was chosen as the inner table of the merge join. When we look at the tooltip window of the merge join operator, we can see that the operator was running as a many-to-many operation. SQL Server assumed incorrectly that we have duplicate values in the join column of the outer table because there is no supporting index nor a check constraint defined. Because of the assumed duplicate values, SQL Server also created a so-called work table in DempDB, as we can see from the output of the session option statistics.io that I have enabled previously. Let's create a unique non-clustered index on the second table. That's the table that was previously chosen by the query optimizer as the inner table of the merge join. Now when we rerun our query, we can see that the execution plan has changed. The query optimizer has rearranged both tables and now uses the second table as the outer table of the join, because it knows now that we have unique values in that table, and because the rows are directly read from the created non-clustered index, the explicit sort operator is also no longer needed. We have achieved a sorted input by adding a non-clustered index. When we now look at the merge join operator itself, we can also see that the many-to-many operation is now not present anymore. We are dealing with unique values in the outer table, therefore we have also eliminated the work table that was previously created in DempDB. And when we finally create a unique non-clustered index on table 1, the other sort operator can be also eliminated from the execution plan, as we can see when we rerun the query again. As you have seen from this simple demonstration, the prerequisite of a merge join is always sorted input, achieved through a supporting index or through an explicit sort operator in the execution plan. In this SQL Server Quickie, you have seen the basic concepts behind the merge join operator in SQL Server. A prerequisite of the merge join operator is always a sorted input. Sorted input can be achieved by creating a supporting index on the join column. If no supporting index exists, SQL Server will introduce an explicit sort operator which will hurt your performance because it needs additional CPU cycles and a memory grant. As you have also seen, the merge join operator supports a many-to-many operation if you don't deal with unique values in the outer table of the join. If a many-to-many operation is executed, SQL Server will also create a work table in DempDB which introduces an additional performance overhead. Therefore, it's always a good idea to create a unique index on the join column to communicate the uniqueness of the data to the query optimizer. I hope that you have enjoyed this SQL Server Quickie, and I already look forward to talk to you next month. Thanks for watching and stay tuned. Value of 8, no match. Value of 10. You always need a very very, very good planning when you're recording a good SQL Server Quickie.